geometry. We are continuing through PO64, the last day of our last objective of our first unit. And we started this one yesterday with the root of 5 minus x minus 1 equals x. And we're going to take it from the top. You already have this work down, so please follow along. When we were all done yesterday, there were a number of people that said they were lost somewhere along the way, they didn't get something. If that happens, if I do something you don't get, don't wait until the end and say you don't understand anything. Stop me in that moment. Say, what did you just do? What kind of math sorcery just happened here? Yeah. Otherwise, you get to the end and then you really don't know where you went wrong. Okay? So, like we talked about, in order to solve a radical equation, at some point we have to square, because that's what undoes the root. And in reality, your initial goal should be to get that root by itself, because whatever's under the root is trapped there until we square it. Okay? So for this first one, what's under the root is 5 minus x. The negative 1 isn't, so we can move that over. And that was our first step yesterday. Okay? The opposite of subtracting 1 is adding 1. So we cancel that out. We get the root of 5 minus x. And that equals, on the right side, x plus 1. Not 1x, because that would be 1 times x. Okay? X plus 1. We're adding 1 to whatever x is here. So far, so good?
Yeah.
Okay. Now, because the root's by itself, and there's nothing we can do with what's inside the root, we square it. And here's where things, I think, started to go awry. On the left side, exactly what we want to happen happens. The root and the power cancel out. And that leaves us with just what's inside the root, 5 minus x. The root just drops out. Yes? We square it because the opposite of taking a root is using a power. ER in PERMDAS, right? If the operation here is a radical, to undo that, we would use an exponent. And because this is a square root, then we square it. Good? Thank you for that. Okay, anything else? All right. Now on the right side, yeah, it's a little bit tricky, okay? But we have to square that whole side, and that's where FOIL crab claw box came in. And after you FOIL crab claw box, you get x squared plus 2x plus 1. Anyone confused on how we got x squared plus 2x plus 1? FOIL crab claw box, any of those three methods work. Okay? At this point, we recognize what type of equation do we have? Quadratic, meaning if we were to graph this on the coordinate plane, what would it look like? A parabola. Yes. And so we remember about solving for a parabola, solving for a variable, we have to be open to two solutions, because the parabola could cross the x-axis up to twice. So in order to do that, we can either factor, or we can use the quadratic formula. In order to do either of those, we have to make this left side of the equation 0. We can't have anything else over there. Everything's got to be on the other side. Which means, since there's a positive 5 here, we're subtracting 5 to cancel it out from the left, move it over to the right, and we have to subtract it from the 1, because they're both constants. And then this minus x here, we're adding x to both sides to, on the left side, cancel it out. 5 minus 5 is 0. Negative x plus x is 0. There's only 0 left. This x gets added to the 2x on the right side because they're like terms. We can't add x to x squared, not like terms. We can't add x to the constant. Okay, we have to add it to the 2x. And so now, on the right side, we have our x squared. 2x plus x is how many x's? 3 x's. And 1 minus 5 is negative 4. And that's as far as we got yesterday. And some of you boxed that thinking that we were done, but oh, no, we are not. Okay? Questions on how we got there? Okay. I recommend getting to this point on this page, but then going to the blank page over to do the rest of the work. Just kind of keep things organized. I want to erase this. And we'll pick it up from the top with x squared plus 3x minus 4. Yes, Evan? What's that? Yes, there is paper in the back if you'd like to use.
Wait, so you have to do the thing where like it's plus and times?
So we have options here. X squared plus 3x minus 4 is our equation. And And when you have an ABC quadratic equation, right, it's got an A term, x squared, it has a B term, 3x, it's got a C term, -4, your options are factoring or quadratic formula. Because this doesn't have a coefficient to x squared, it's the easier of the two factoring types. This is PO51, not PO52. I'd recommend trying factoring first. Because all you're looking for are two numbers that multiply to equal the constant, and those same two numbers add to equal the middle term. Are there two numbers that multiply to make -4 and add to be +3?
1 and a negative 4.
1 and -4. Right?
-1 and
1 times -4 is -4. 1 plus -4,
No, it's the
that's
other way.
-3. Right? It's the other way around. -1, +4. -1 times +4 is -4. -1 plus +4 is +3. Check your work. Okay? So now, we have 0 equals, remember this? X minus 1 and x plus 4. Right? Okay? What does x equal?
We don't know yet.
We do. Because if the product of these binomials equals 0, remember what we're looking for?
0.
What value for x makes this equal to 0? 1. Because if this equals 0, it doesn't matter what that equals. 0 times whatever will still be 0. Right? Remember this one last year? Yeah? And then for our second set, what value for x makes this equal to 0? -4. It doesn't matter what the first one is. If this equals 0, anything times 0 will still be 0.
What's the one where the one is answer is always zero?
That's if you don't have a C term. If you just have an A term and a B term, an x squared and an x.
I like that one.
Evelyn,
This one is already faster.
sorry?
We just do faster.
Sure, if you want to use a quadratic formula, be my guy. Yes, that'll work too. Okay, that'll work too. So now, we talked about extraneous solutions here. Okay? We calculated x to be both 1 and -4. The problem with guess and check with radicals is that if there are two solutions that work and you find one of them through guess and check, you don't know if you're done or not. There might be another one. So then you have to go through guess and check again. Okay? By doing it this way, we know what our solutions could be. We have to check them both to see if they are going to work. So what we do, we go back to the original equation. Our first solution of x equals 1, we say, does the square root of 5 minus 1 equal 1? That's a lot of ones. This one here came from plugging in 1 for x,
It does.
because we have that value here. This one here came from plugging 1 in for x, because we said x equals 1. This one just happens to be a part of the equation to start with. So, if we take 5 minus 1, we get 4. The root of 4 is 2. 2 minus 1 equals 1. Got it. Checks out. This one's good. Okay? If we plug in -4,
It don't work.
if we're trying x equals -4, the square root of 5 minus -4 minus 1, does that equal 1? Because x is a negative value, we need this minus negative in there. 5 minus -4. What's 5 minus -4?
Why does it have to be -1?
Sorry, -4. Whoopsie-doo. No time for the song.
You do, what?
Okay? What's 5 minus -4?
9.
9. Root of 9 is
3.
3. 3 minus 1 is
2.
not -4. So this one is extraneous. It does not work.
Why does it work?
Okay?
So you have to plug it in.
You
otherwise-
have to check it. If you gave me both answers on a test, it would be incorrect because x does not equal -4. Okay? It only equals +1. Sometimes both answers will work.
So sometimes you have one, none, or 2.
Yes.
Yeah.
just like a parabola. Sometimes you have no x-intercepts, one x-intercept, or two. Yeah?
If it's like one of the things was if there's no c, is there gonna be a 0 as one of the x's?
Yes. If there's no constant, then one x will be 0. Okay. What's another one you want to go over?
Wait.
Priya.
Last one.
Sends. Why doesn't the 4 work yet?
Because if you plug it in, 5 minus negative 4 gives us 9. The root of 9 equals 3. 3 minus 1 does not equal negative 4. Okay. Evan, which one do you want to talk about?
Last one.
The last one.
Does
Very
X-
well.
Does X equal 1 then?
Oh, for this one?
Yeah.
Yes, x equals 1.
So there can be one answer?
Yes.
I had it right the whole time.
Good. Okay, here we go. Last one. The root of 2x plus 77 equals x plus 7. There's nothing else with that root. The root is by itself. So what do we get to do right off the bat?
Exponent.
Square it. Okay? If the root is by itself, nothing else is over there. The only thing we can do is square it. So when we square it, what happens on the left, we want to happen. The radical and the power cancel out. And that gives us 2x plus 77. What happens on the right is a little bit messier because we have to square that whole side. So you, once again, get to FOIL, crab claw, or box. Go ahead and do that and let me know what you come up with. X plus 7 times, remember you can't distribute the power. This is really x plus 7 times x plus 7, which is why we have to FOIL, crab claw, box it.
That's done. Foil.
Okay, what do we come up with? Aiden.
X squared, 14x, and 49.
X squared plus 14x plus 49 is correct. Okay? If you use the box method, or really regardless, you end up with x squared, 7x, 7x, and 49. Those two 7x's then combine to make 14x. Okay? So we see we have a quadratic equation. We've got the power. It's going to be a parabola. We have to quadratic formula factor, or whatever we want to do. But before we can do that, we have to get the left side equal to 0, just like before. So we have to subtract 2x from the left side, subtract 2x from our 14x's there, and subtract 77 from the left side, and subtract 77 from the 49. Because on the left side, 2x minus 2x cancels out, 77 minus 77 cancels out, we end up with 0.
Okay, I got x
Okay.
squared.
So x squared
Minus,
plus 12x
what's the negative? 28.
minus 28.
Alright.
Okay?
Not too hard.
Right now, third one.
This one is factorable. If you want to use the quadratic formula, you certainly can. But our number puzzle, two numbers that multiply to equal negative 28, and those same two numbers add to equal our middle term 12. What do people see here?
Yeah, 4 and 6.
4 and 6.
No, never.
No.
Evan,
14 and negative 2?
14 and negative 2. 14 times negative 2 is negative 28. 14 plus negative 2 is positive 12. So, our parentheses, we have x plus 14 and x minus 2 equals 0. We take that solution to the number puzzle, put it in our parentheses, which means that x equals
Negative 14.
negative 14, or x could equal positive 2. right? We want to make each set of parentheses equal to 0. Negative 14 plus 14 is 0. 2 minus 2 equals 0. Now, we gotta check.
I don't like checking.
Okay? So we go back up here. We'll check the negative 14 first. So we have if x is negative 14, we have the square root of 2 times negative 14 plus 77, and that has to equal negative 14 plus 7.
Your guessing and checking worked again.
Good for you, Chance. Good for you. Yes?
I got x equals 2.
What's that?
I got x equals 2.
Good. Does negative 14 work?
No.
Why not?
Because
If it's negative, it's not.
So what do we get from the square root of 2 times negative 14 plus 77?
there's 81.
We get
7 equals negative 7.
we get the root of 49, right? Negative 14 plus 7 equals negative 7. Is the root of 49 negative 7? Now, we did talk about last year that the root of 49, if you're solving for a parabola, you do need to include both 7 and negative 7 because they're the two x-intercepts, right?
Yeah, but 7, negative 7 times negative 7 is 4.
However, in the, what's that?
Negative 7 times negative 7 is 49.
Okay, so could this work?
No.
Yes.
But if you put 49,
It could be positive 7 or negative 7, because negative 7 squared
Oh, yeah.
does equal positive 49. So does negative 14 work?
Yep.
Yes, it does.
Wait, but what about the negative 14 plus 7? So both of them?
That equals negative 7,
so they both.
and the root of 49, one of these solutions is negative 7, because negative 7 squared equals 49. Welcome to the big wide world of radicals and exponents and parabolas and things like that. Okay, just like we learned last year, with a parabola having potentially two answers, because roots are the opposite of exponents, and it's the exponent that makes it a parabola anyway, it would make sense those two things go hand in hand. Okay, this is another operation where you need to be open to two solutions, which is why guessing and checking is not the recommended
best.
method. You don't know if you're looking for one solution or not. Let's try 2. If x equals 2, we get the root of 2 times 2 plus 77, and we want to know if that is equal to 2 plus 7. Well, 2 times 2 is 4, plus 77 is 81. Is the root of 81 equal to 9? Yes, it is. So it turns out that 2 also works. You would need both solutions. Chance, through guessing and checking, did you by chance get both solutions?
No.
Whoops.
Wait.
Do the method. Aiden.
When I was guessing and checking for the when we did first, I got 1.
Right.
Same.
And it happened that that was the only answer. This one happens to have 2, and you need them both.
Yeah.
So the problem with guessing and checking is you might stumble upon one solution, but you don't know if there's another one. How do you know to keep guessing and checking?
Keep going and you fail.
Right?
Is there ever a possibility where there's more than 2 solutions?
Not for this. There will be eventually when you start talking about sine graphs and cosine graphs and tangent graphs, all those things. But that's trigonometry.
Okay.
Yes.
Do that work out to a whole number, or?
These will work out to a whole number because in the spirit of Christmas, it's your first time going through it. I'm being kind of nice.
Yeah.
But you don't know whether there'll be 1 or 2 solutions. So you have to test them both. Yes.
Well, we have, looks like it's, well, we have to do proofs this year, that's a,
Yes. Once
Why?
we start to geometry. Proofs are a big part of geometry.
what are those?
Geometry is
Like proof
the
is
study of
like-
mathematical relationships, and you can't state a relationship without proof.
What's proof?
We'll talk about that in geometry.
Tell us now.
Right now, your proof is showing the work. I mean, we'll do algebraic proofs, which is essentially showing your work to solve an equation. This is the algebraic form of proofs. Geometry proofs we'll talk about later on. Yes?
-7 minus -7
7 is 0, right?
Negative 7 minus negative 7 is 0, yes.
Wait, what?
Congratulations.
Negative 7 minus negative 7 doesn't equal 0. Okay, we've got time to do another one. Look at how, we only got 3 of them left. Ella, down.
Middle
down.
First one down.
Yeah.
That one.
This one, okay.
I couldn't guess and check a single one of those.
Couldn't guess and check it, I'm sorry.
And that one was same as this one.
The root of 14x plus 72 equals x. The root is by itself. Thank your lucky stars. You can go ahead and square right off the bat. And the best part of this is there's not even other junk on the other side. It's just x. It's just x squared. Things couldn't be better. Okay?
Yes, why did we do that?
On the left, the exponent and the root cancel out like we want them to. We get 14x plus 72 because that root just drops off. And on the right side, the only thing we're squaring is x, so we just get x squared.
It's still a quadratic.
It's still quadratic, yes, but at least it's not foiled crab claw boxing here, right?
That's really dumb.
Whether or not you want to use quadratic formula or factoring is up to you. But I do recommend, I recommended this last year also, it is fewer steps just to move our x squared over to the left, but that's going to make it negative. And trying to factor a negative a term adds in some complications because of where the sign goes in your parentheses. It's not clear. So even though it's moving 2 things over to the right, I would still recommend subtracting 14x and subtracting 72 to get 0, giving you x squared minus 14x minus 72. It's just easier to factor if your a term is positive than trying to factor it if it's negative, because that sign can cause some problems. So, 72. Let's try the number puzzle just because it's likely it works out, because spirit of Christmas, all that stuff, right? 2 numbers that multiply to make negative 72, same 2 numbers add to be negative 14. Jonas?
Negative 18 and
Negative 18 and positive 4. Negative 18 and positive 4. So our parentheses, x minus 18, x plus 4, all that equals 0. Our solutions, what value for x makes this 0? 18. What value for x makes this 0? Negative 4. Do they both work? Does only one work? Let's find out together. So we go back up to the top. And we say if x is 18, if this is indeed the case, then the square root of 14 times 18 plus 72 will have to equal 18. What is 14 times 18 plus 72?
Probably a big one.
252.
Jonas?
3, 2, 4.
What's the root of 324?
18.
18! This checks out.
The other one I said?
That's okay.
Okay? If x equals negative 4, I'll do it down here. If x equals negative 4, we've got the square root of 14 times negative 4 plus 72 equals negative 4. What's 14 times negative 4? Negative 56. What's negative 56 plus 72?
I just put the whole thing in my calculator.
16.
Square root of 16 is 4.
Can the square root of 16 be negative 4?
Yes.
Yes, it can, because negative 4 squared equals 16. So this one works as well. You okay, James?
I think water went down the wrong. Sweet.
Okay, when that happens. Okay? So again, if you guessed and checked, you may have stumbled upon one of them, but you don't know whether or not you are completely done. Okay? I left my pre-algebra class to fill my water bottle during the first hour today and came back to this. So, lesson learned. Don't leave your classroom. Yeah.
Is that not a tip?
What's that? Oh, no, it's fine. They come off easily.
Usually.
You saw that.
They are.
very
They make
So
sense.
I can go
Okay,
put a
your
sticker
homework
on
for
that.
tomorrow, there's only three we have not done. Do them, check for extraneous solutions. Let's see, we did, okay.
When am I getting
Wait, can we
this?
put
Okay,
it-
okay.
exercise sugar?
What's that?
Slideshow.
Yeah, hold on, let's,
No.
are we all good?
Yeah.
Okay, homework, the three we did not do, due tomorrow, practice test tomorrow, test Thursday, Friday. That's how you math.
Don't like
Like,
this.